Hey students, welcome to lesson 67. Today we're going to be talking about our inverse trig functions. Now in our lesson today, you are going to want to use that paper I gave you during class right before our break, the one that had the circle on it. We were starting to make some notes on that. If you've lost yours or maybe you actually left it in your locker somewhere, just go ahead and send me an email and I can send you a new copy because you will need to use that in our lesson both today and tomorrow. Just like lesson 66, we're going to break this up into 2 different days because there'll be a lot of different things that we'll take a look at here, and I don't want to overwhelm us trying to do it all here in one day. So let's do just a little bit of review about what we talked about before, and some of this already should be on your paper about your circle. If you just got a new circle or you forgot to write it down before, then please make sure that you do it today. In our Cartesian plane, what we had in our circle, we had used some special definitions for sine, cosine, and tangent. What was our definition for sine originally? It was opposite over hypotenuse. Well, as we switch it to the Cartesian plane, we came up with some new definitions, and that definition was y over r. Remember that memory help we had was syrup, so y over r. Well, in the Cartesian plane, we had noted that the r was always equal to 1. So that meant our sine definition turned into the letter y. So all of those ordered pairs that I see around the circle, the y, which is the second number inside the ordered pair, always gives me the answer for sine for the certain angle. What was our definition for cosine? It was x. And then what was our definition for tangent? It was y over x. So make sure that you do have those somewhere on your circle. The sine was our y, cosine was our x, and then tangent was y over x. There's one other thing that should be on your circle, and I'll review that as we're getting into our lesson. So if you don't have that on there, I'll have you make sure that you put it on there at that point as well. Just walking through a couple review questions that we've done before. What we've answered before is we've evaluated a certain trig function, like what's the cosine of 30 degrees, and you can look at your picture to find the final answer. So you were given the angle, I gave you a certain degree measurement, you were able to answer the question. So like this problem, the sine of 30 degrees. Well, I look at my circle and I find 30 degrees, there it is up there in quadrant number 1 on that top right-hand section. Well, the sine is the y that I see from the ordered pair. What y do I notice there? 1/2. So the sine of 30 degrees is 1/2. Just doing one more question here, if I said the cosine of 45. Well, 45 degrees, I find that on my circle. It's also in that top right-hand section, quadrant number 1. In order to locate cosine, it was the x that we had in our ordered pair. What was the x that we had for 45 degrees? It was square root 2 over 2. So there was our answer for the cosine of 45 degrees. Now, in our question today, we're supposed to be looking for our inverse trig question, which means we're going to be given the trig, we have to find the angle. We're going to be given the answer like that 1/2 or root 2. Our job is to give the angle that actually corresponds with that final answer. So we're going to have to use inverse trig to help us do that in our questions. Now, just some terminology so we understand what the questions are going to be set up as. So if the original question is a sine function, it says sine of theta. Remember, theta was an angle. So the sine of some angle equals a. Now, a is going to be the ratio that you see in the chart. So sine of a equals 1/2. Well, then my job would be to find the angle that has a sine of 1/2. I would have to look at my picture and find where do I see a y that is 1/2. Well, here's the notation that it says. It says the inverse relation looks like this. Sine inverse, that's with our -1 exponent of whatever ratio that I saw from the chart. So sine inverse of 1/2. Sine inverse of root 2 over 2, whatever, equals our theta. In our lesson tomorrow, we're going to have to use our calculator to help us come up with the answers because they're not going to be on our circle. And just make sure that you can correctly find them in my calculator. I notice I have my sine, cosine, and tangent, and the inverses are right above mine where it says like the sine inverse, cosine inverse, and tangent inverse. So make sure that you know where to find those on your calculator as we're going to have to use those tomorrow. So the same thing happens for cosine as well for tangent. If the original question said cosine of something equals root 3 over 2, well then my job is to look at the picture and see what angle has that ratio. So I'm using my cosine inverse, and the same thing for tangent in our question. Now let's actually work through a couple questions like we've done before, and we're going to tweak them so we can see what's happening in our questions today. So inverse trig. Now, inverse trig, they are not functions by themselves. So what does that mean? A function did not have repeating answers. I give one and only one answer in the question. Well, that's not going to be the answer for the questions we're talking about today, because there might be two answers, or there might be an infinite number of answers in our questions. So there's going to be many values of theta, or many answers, many angles for a particular ratio that is given to us in our problem. Like, for example, if I said cosine inverse of root 2 over 2, well, what does that question mean? I am looking for the angle that would give me that ratio for cosine. Well, I'm going to use my circle to help me locate that. What was my definition of cosine? That was the x. So I'm going to look at my circle, and I'm going to locate where do I see a root 2 over 2 for the x. Well, if I take a look at my circle here, where I see root 2 over 2 for x is at 45 degrees, or I can list that in radians, pi over 4. But I also see root 2 over 2 for the x down at 315 degrees, and that was at 7 pi over 4. I have two different angles that met the requirements for the ratio that was given to us in our question. Now, unfortunately, those aren't the only two angles, because we can also have coterminal angles. Now, we talked about coterminal angles a while ago. Those are the ones that I kept rotating around the Cartesian plane. To rotate around the Cartesian plane, I would add 360 degrees because I'd spin around the circle. Well, my first answer, 45, well, if I add 360 to that, gives me 405. So the cosine of 405 is also root 2 over 2. So I'm going to show you how do we set up our answers for every certain kind of question, because sometimes I want all of the answers, which means I want to keep spinning over and over. Sometimes we're just going to give one answer, and we'll know why that's the case. And some questions will just give the two answers that I see out of the Cartesian plane. So let's start off with a first question where it says to describe all of the values. Now, that's a key word there where it says to give all of the values. When it says to give all of the values, that means I want to keep spinning around the Cartesian plane as many times as possible. I don't want to just give the angles that I see in the picture. I mean, those will help me start the question, but I want to give all of the possible answers to our question. Okay, so how am I going to come up with this? The answer says tangent inverse. Okay, so all that means is I need to give the angle that has a tangent that corresponds with our question. Well, our tangent definition was y over x. Notice the ratio that I gave you here was negative root 3. Well, the only way to have a fraction and I get a negative answer is somewhere in the fraction there's a negative. There's either a negative on the top or there's a negative on the bottom. So that means either my y has to be negative or my x has to be negative, but not at the same time. Well, where on the Cartesian plane do I see just y negative and not the x negative? That is located in quadrant number 4. So I'm going to find an answer down in quadrant number 4. Where on the Cartesian plane do I see the x being negative, but the y is positive? That's up in quadrant number 2. So that's going to help us find the other location on the circle for our two original answers on this question. Now, the tangent y over x. Well, how do I know what is going to give me root 3? When it comes to this kind of question where you have the square root in your original problem, you want to find the y on your Cartesian plane that has that same square root. Well, if I look at the Cartesian plane, which of the y's up there in quadrant number 2 contains the root 3? It's 120 degrees. So the first answer that I would give is 120 degrees. Now, I listed out in radians 2 pi over 3 as well. Now, here's the extra thing that you're going to have to do when it says to give all of your answers. All of your answers means you want to keep spinning around the Cartesian plane. So let's focus on the degrees first. Well, going around in a circle is 360 degrees. So there was my original angle of 120 degrees, and then plus spinning around the circle 360 degrees times n. Now, n is just how many times do I spin around the circle. So I would always put 360n if it wants me to give all of the answers in this question. If I look at my first answer that I gave in radians, 2 pi over 3, that was the radian measurement for 120 degrees. Well, notice at the end of this part of my answer, it says plus 2 pi n. If you look at your Cartesian plane there, if you look at your circle, notice over there where it says 180, it says pi. So that means 360 is twice as much, so 2 pi. So 360 degrees is the exact same thing as 2 pi. There's the n that I want to put at the end because I can keep spinning around the circle as many times as I want to. Now, I would not give both of these answers. I would just give one of them. I'm just showing you the two different ways that you can write from this 120-degree angle. Now, unfortunately, that's not the only place on the Cartesian plane where the tangent is equal to root 3. All that we focused on so far was in quadrant number 2. Remember at quadrant number 4, we also have one positive and one negative, which means my fraction for y over x would turn out to be a negative, which is what I want here in the question. So what angle down there is the y containing a root 3 that's at my 300 degrees. So if I'm giving all of my answers, notice I did 300 plus 360n, again 360 because of the rotation, n, how many times did I rotate? And then the other answer is the radian answer of 5 pi over 3 plus 2 pi n. Okay, so please keep in mind, if it says to give all of the answers, you have to include that addition part of your final answer so that way you can continue to spin around the Cartesian plane. Again, n is just some integer telling us how many times that we can move around the Cartesian plane. I'm going to go ahead and stop this video right now, and then we'll pick up with the continuation of this first part of lesson 67.